Hey, my name is Lainey Bergeron, and today I'll be giving a brief rundown of the structural design of the Classic City townhomes that my team and I have been working on over the past year. My team consists of Ashley Moore, Jillian Fieser, Eric Fuqua, and myself. We have been working closely with Armantrout Matheny Thurmond and Dr. Trezeppa to design a townhouse complex that will provide affordable housing for families in Athens, Georgia. After having the first meeting with the client, the team was able to identify the stakeholders associated with the project as well as what was expected of the team throughout each semester. When working on any project, the team understands that the community's health and welfare are a top priority. Many codes and jurisdictions have been followed to ensure that the townhouse complex is structurally sound and therefore keeps the public safe. The existing conditions of the site include approximately 43 acres of land located off of Hull Road in Athens, Georgia. Surrounding the site includes multiple businesses that would benefit from the proposed townhouse complex. The townhouse complex can provide a large influx of cash flow for the surrounding businesses, whereas the businesses may provide job security for future tenants of the complex. The goal of this project is to provide affordable housing for families in an ever-growing community. As Athens continues to grow, it is becoming more and more difficult for families to set their roots here due to the increasing price of homes. Throughout the course of the project, the team conducted multiple tests using computer programs to analyze different material options and determine the most cost-effective yet structurally sound townhouse complex possible. As shown in the picture to the right, the team went on a site visit to better understand the needs of the client as well as the community. Before the team was able to conduct any test, all the loads on the townhouse complex need to be determined. In order to create a structurally sound home, it needs to be able to withstand all the dead loads, live loads, wind pressures, and seismic forces acting on the building. The client AMT has provided the team with architectural drawings of the floor plan for the first and second floor as well as an elevation view of the townhomes. As seen in these drawings, one building consists of 4 two-story units with load-bearing walls being all the walls that run from north to south. The townhouse complex is to be built with brick veneer, allowing for an aesthetically pleasing view for the community. The floor framing was designed using testing analysis through Louisiana Pacific software in order to determine the most economical I-joist and header sizes. After analyzing the data, it was determined that the most economical depth for the I-joist and headers is a depth of 14 inches. This larger depth allows for the I-joist to be spaced 24 inches on center, therefore requiring less I-joist overall. The I-joist will be a common prefabricated member, therefore allowing for a faster on-site construction time. Headers will consist of 2-ply LVL with a total width of 3.5 inches to carry the stair live loads. The OSB rim board will be in place to allow for easy connections of the I-joists. The ceiling framing plan was designed with economic decisions in mind. The ceiling joists span in the 18-foot direction because that is the shortest and therefore most cost-effective option. The beams are 2x10 No. 2 Southern Pine, spaced at 16 inches on center. This is a common lumber and therefore will not be difficult or expensive to obtain. The spacing was chosen in order to ensure the structural integrity of the building, while also maintaining economic choices. There is a 2x10 No. 2 Southern Pine rim board that runs around the perimeter of the framing. Each unit also contains 2 LVL beams in the ceiling framing that support the load of the purlins in the roof framing. The roof framing system consists of rafters that are 2x6 No. 2 Southern Pine at 16 inches on center. This material was chosen with cost-effective decision-making, similar to other framing systems. There is 1 LVL ridge beam per unit. The size of the ridge beam was also determined using software analysis, and the most economical size was determined to be a 1.75 by 14 inches. The material used is LP LVL 2900 FP 2.0E, because this is a very common material for this purpose. 2 vertical supports at the midpoints are braced down to the LVL beams in the ceiling framing. The eaves extend 1 foot 6 inches beyond the exterior siding. There are a total of 55 frames per building. The wood wall panels will use 2x4 No. 2 Southern Pine members. The wall studs will be placed at 16 inches on center. The materials and spacing of the wall framing was chosen by considering safety, price, and availability. Exterior walls are sheathed with 7/16 inch OSB on the exterior and 5/8 inch gypsum sheathing on the inside. The foundation plan was determined using the International Residential Code as well as the American Concrete Institute. It was determined that the concrete slab will be 4 inches deep with strip footings along all exterior walls as well as all interior load-bearing walls. The slab will be on grade and will be reinforced with welded wire fabric that is discontinued at each saw cut joint. This discontinuation allows for a smaller required area of reinforcement, therefore allowing for a more cost-effective approach. The exterior strip footings include a 6-inch ledge that allows for the brick veneer to sit on. Both types of footings include steel reinforcement to ensure it will hold all the loads from the building. My team and I would like to say thank you to James Wilson from A&T for sponsoring this project. We would also like to say thank you to Dr. Giuseppe and Dr. Durham with the University of Georgia College of Engineering. This project would not have been possible without the support of our community.